Look closely at any modern building or bridge and you'll see them, tiny hairline cracks. They look harmless, but they are the silent killers of our infrastructure. Traditional repairs are costly, slow, and terrible for the planet. But what if concrete could heal itself from the inside out in just 12 days? My name is Professor Engineer Dr. Upagaram Johnson Alengaram. I'm here to introduce a transformative solution from the Faculty of Engineering, University Malaya. Self-healing of concrete cracks using microalgae and development of self-healing of concrete cracks by using microalgae, BioCrete. We've developed a sustainable, bio-based approach that turns concrete from a passive material into a living, self-healing system using microalgae called Arthrospira, platensis, a specialized blue-green microalgae. So the thing is, in any concrete structure, it generally starts with tiny cracks, which lead to major cracks, which lead to uneven structures, which might lead to severe damage. Here, the first thing you need to focus on is the minor cracks that need repair. Yes, you might be thinking that, it can be repaired or reconstructed, that cracked area, right? Yes, somehow it might be right. Yes, there are existing solutions to mitigate the cracks, but the fact is, those are not eco-friendly, cost-effective, and time-consuming process techniques. And these techniques won't treat the cracks from the inner part of the concrete matrix. So, how does it work? Our technology utilizes microbially induced calcite precipitation, or MICP. We culture microalgae using concrete wash wastewater, turning industrial waste into a powerful healing agent. When applied to cracks, these microalgae trigger a biological process that produces calcium carbonate crystals, effectively sealing the wound from the inside out. The results from our lab are groundbreaking. We have achieved effective crack closure within just 12 days. More impressively, our treated specimens showed up to 97.8% recovery in compressive strength. We aren't just filling gaps, we are restoring the material's structural integrity to nearly its original state. The impact of BioCrete goes far beyond the lab. By integrating waste valorization and carbon sequestration, we are offering a circular economy solution that reduces the massive carbon footprint of the construction industry. For those managing large-scale infrastructure, this means significantly extended service life for structures and a dramatic reduction in long-term maintenance costs. We are creating a future where buildings maintain themselves, waterproof seals are autonomous, and our materials actually help clean the environment by reducing cement consumption. This is a sustainable, smart technology ready to revolutionize how we build and rehabilitate our world. With a proven track record of success in the lab, BioCrete is now ready to transition from research to the global market. We are moving beyond the prototype stage and are seeking strategic partners to help us scale this technology into the hands of developers and engineers worldwide. By investing in BioCrete, you are investing in a smarter, longer-lasting, and environmentally responsible world. Because the best way to fix our infrastructure is to teach it to heal itself. Join us and let's build a resilient world together.